This video is about AI for art interaction. Did you know that working with a digital museum collection isn't that hard? Even my 7-year-old daughter can do it now. I first want to talk to you about visual information retrieval. What does that mean? Well, retrieval means you want to find something. And the most familiar retrieval system is Google. Google uses language to query or to ask questions about the web of documents, the World Wide Web. But we have collection systems, right? They work with visual data, they work with artworks. Yes, of course. But also these are text-based, because they don't look at the image, they look at the metadata. But can we have a system without metadata, with only images, with only pixels? And I would say yes, that system is a visual information retrieval system. Let's try to imitate Google. We take a piece of text and we want to use it to query images, a visual information retrieval system. In a project called Collectie van de Gentenaar, we built a system like that, where a user could input a word and retrieve images that are similar to that word. One example being we queried for flowers and we got all sorts of images related to flowers. Or similar, we queried for a red car and we got only red cars. But how does this work? Another thing you can do in a system like that is to input an image. You can do a thing called reverse image search, where you look for images that are semantically similar. That means that pictures can look very different in appearance, as long as the content or the topic is similar, and then they will come out on top. So if I query with a chair from the design museum in that project, I will find other chairs, but I will also find a bench in a park. And sometimes even the algorithm gets a little bit confused and you get funny results like a bridge, which is something you can sit on as well. The model behind all of this is a multimodal AI. Multimodal means that it can work with both images and text at the same time. The CLIP model we used is a deep learning model that is trained on pairs of images. So you have descriptions and you have the image. And the model learns to relate those two. So internally, what the model does is it creates a numerical representation of what you input. So if it's text or an image. So if you give it the text hedgehog or an image of a hedgehog, in fact, the model will turn these two bits of information into the same numerical representation. So it thinks these things are the same. It can do all sorts of transformations. You give it a text, it will look for similar images. You give it an image and it will search for a text that could describe the image. And if you give it an image, it will look for images that are semantically similar. Okay, that was multimodal search. My daughter, however, still needs to learn how to type. So the search query we want to do, or the retrieval, has to be even more simple. Do we have anything else? Well, if you would know my daughter, or any 7-year-old, you would know that, well, they can mimic things or imitate things. They could imitate an artwork. So she could pose in front of a camera, and we could build a pose search system that processes her image and tries to find images that have a similar pose. You could call this pose retrieval. How does it work? Well, in human pose estimation, that's again a deep learning technique, the model tries to fit a skeleton to a depiction of a human. That means it tries to find the joints. It tries to find the shoulder, the hips, the feet, the hands. Fit them, and so you have a skeleton. That model will do that for my daughter in a live fashion, and will do that on an art collection one time previously. You can do that to pre-process that, and then compare the skeletons with each other and find the most similar skeletons and show them as a result for the retrieval operation. So finding the best pose is again a similarity calculation. The human pose estimation model learns from labeled poses and gets a higher and a higher score if it gets better at positioning the joints. That's how it learns. You don't necessarily need an image to start from. You can also draw the skeleton yourself and use that as a query operation. So we saw that systems like Google and metadata-based systems are not the only search systems in town. Visual information retrieval systems could use multimodal AI or perhaps pose estimation to query. So you can query with your body. Do you think that based on all of this, do you think that there is a future for human data annotation, or will these types of search operations replace it? My daughter isn't convinced.